Okay, we've got this question here. Suppose suppose that the market for milk can be represented by the following equations. Demand P equals 12 minus 0.5 QD. This is the demand equation. It shows the relationship between price and quantity demanded. Remember, there's an inverse relationship. So when you graph this equation, you have a downward sloping line. We're given the supply function, which was the relationship between price and quantity supplied, which is following the law of supply. So P is the price per gallon, and Q represents the quantity of milk represented in millions of gallons of milk consumed per day. Part 1. Calculate the equilibrium price and quantity of milk. So, colleagues, when calculating the equilibrium price and quantity, always equate the demand and supply equations, right? Demand and supply equations. So, the demand equation is 12 minus 0.5 QD. Supply equation 0.1 QS. So when you're calculating for equilibrium, this QD and QS don't matter because the quantity that will be demanded will be the same as the quantity that is supplied. All right, remember that. At equilibrium, the quantity demanded QD is equal to the quantity supplied. So in this case, we'll just leave it as Q here. So one find what's the value of Q. So this is all about algebra, like terms. This negative 0.5 Q, we are going to take it over this side. So we remain with 12 equals 0.1 Q plus 0.5 Q. 0.1 plus 0.5, 0.6 Q. To get the quantity, divide both sides by 0.6. 0.6 divided by 12, you get 20. So Q 12 divided by 0.6, that's 20 million gallons of milk. This is the quantity demanded, and this is the quantity supplied at equilibrium. Any questions, colleagues? When you find the equilibrium quantity, next you can get the equilibrium price. So in order to get the equilibrium price, this Q equals 20 You can either substitute it into the demand equation, or you can substitute it in the supply equation, whichever. So in this case, I'll work with the easier one, the supply equation. P equals 0.1 Q. Just substitute Q with 20. 0.1 times 20, the equilibrium price is 2 kwacha. So that is the equilibrium price and the equilibrium quantity. Any questions? Okay. To help dairy farmers, the government sets a minimum price of 2 kwacha 15 ngwe per gallon of milk. What is the new quantity of milk sold? Yes? Yes, you have a question? QD and QD and QS equals 20, because at equilibrium, QD equals QS. Okay. At equilibrium, Q, the quantity demanded, is equal to quantity supplied. So here, there's no need to put them when you're trying to solve for Q. Okay. You just leave Q as a blank Q. But whatever that value of Q you get is going to represent QD and QS. Is that okay, sir? All right. So we are on part two. They're saying to help dairy farmers, government sets a minimum price of 2 kwacha 15 ngwe per gallon of milk. What is the new quantity of milk sold in the marketplace? So we just get that 2.5 kwacha, put it in our supply function, so that we can get the quantity supplied at this price, 2.5 kwacha. So this is a price floor that has been enacted here, because it's the minimum price. So a price floor has been enacted of 2 kwacha 50 ngwe. So these guys can sell the milk at 3 kwacha 50 ngwe, 4 kwacha, 5 kwacha, and above. Right? So we want to find out one the new quantity of milk sold at this price. So you're going to look at the supply function. So you say 0.1 QS. The price has been given to us, which is 2.5 kwacha. Want to find QS. So 0.1 divided by 2.5, you get 25 million gallons of milk. That is the quantity supplied. Right? 25 million gallons of milk. So the next part is we have to show all of this information on the supply and demand graph so that we see what happens when government enacts this price flow, what happens in the market. And if you remember, whenever a price flow is enacted, you're going to see a surplus. And here we can already see the quantity that's demanded is 20 million. Now the quantity that's supplied is 25 million. We're seeing a surplus of 5 million gallons of milk. So that's theoretical, right? Remember, all of this is theoretical. Now, as I said, for the supply and demand functions, you need to get the y-intercepts. Why you need the y-intercepts? Because you have to know where the graph is starting from. If you don't know where the graph is starting from, you're going to put the wrong information. All right, so we need to get the y-intercepts. A y-intercept is just where the graph cuts the y-axis. Okay, that's what the y-intercept is. Okay, where the graph cuts the y-axis. So for the supply curve, or the supply equation, which is P equals 0.1 QS, right? Want to find where is this graph starting from, on the where is it cutting the y-axis basically. In order to do that, just equate Q to 0, okay? Because when Q is 0, you are just focusing here on the y-axis, so you equate Q to 0. So for the supply function, we're going to say 0.1 times 0, the price is 0. 0.1 is 0. All right, so it means our supply function is starting from the origin here, or cutting the y-axis at the origin. So you draw your supply curve. So it's always important to do this because sometimes some supply curves won't always start in the origin. They might start here or somewhere on top. So you have to know where it's starting from, especially if you're asked to graph these. So yes, our supply curve starts from the origin. It's cutting the y-axis at the origin. Colleagues, are we okay with this? Any questions? That's our supply curve. The demand curve. Uh-huh. Yes. It depends on the type of. Okay. All right. So for example, if you have an equation like maybe 0.1 QS plus 3, maybe if you are given a supply equation like this, all right? If you equate this to 0, 0 plus 3, you get 3. So it means your supply curve will start on 3 here and go up. So it depends on the type of supply equation you've been given. Okay. If it's one which is like this, where you just have a number attached to the variable, you can actually even assume that the supply curve starts at the origin. Okay. If you see one which has a number attached to a variable like this one, because you know if you equate Q to 0, P is also going to be 0. But if your supply equation has a plus something else, you will see that it will start somewhere else apart from 0. Is that okay, sir? So also the same thing for the demand equation. You want to find where is it cutting the y-axis, basically where is it starting from, because usually with this type of graph you never look at the negative sides. Okay, so where is it starting from? So again, qd, you equate it to 0. So you're going to say 12 minus 0.5 multiplied by 0. 0.5 times 0, that is 0. 12 minus 0, that is 12. So where the price equals 12, that's how you draw your demand curve. Not bend like how I've drawn it, but yes, you have a rule and show to show that. Are we okay with this, colleagues? And then the equilibrium price is 2 kwacha, and the equilibrium quantity is 20 million gallons. The government has put a price floor of 2.5 kwacha, so with a straight line you draw this price floor of 2.5 kwacha. This 25 gallons which you just calculated earlier on, it's here. Where this price flow cuts the supply equation, we have 25 million gallons of milk that is applied. Also, we can find what's the quantity demanded of milk at this price of 2.5. So where this price flow is cutting the demand equation. So in the demand equation, we substitute P with 2.5 and want to find the value of QD. P is 2.5 here. So if we solve like terms together, so we take this negative 0.5 QD to this side, to the left side. So we have 2.5. Oh, this QD, not this 0.5, it's got a QD attached to it. We take this 12 to where the 2.5 is. But since I want to make this positive, so what I'll do is I'll take negative 0.5 QD to the left, and then this 2.5 I'll take it to the right, so that at least I just maintain a positive zero point 0.5 QD. So you bring zero point 0.5 to the left, QD equals, I hope everyone's able to see clearly. Maybe let me zoom in. Yes, so here we have 12 minus 2.5. 12 minus 2.5, colleagues, those with calculators, 9.5. Okay, so 0.5 divided by 9.5, 0.5 divided by 9.5. 19. So the quantity demanded for milk is 19 million gallons. So earlier on, I said there's a surplus of 5 million. Actually, the surplus, to get the surplus, you say 25 million minus 19 million, so that we get the surplus. So 25 minus 19, what did you get? So yes, we have a surplus of 6 million gallons of milk. That is the surplus. So as a classical economist, you would say government shouldn't intervene with this 2.5 price floor. They should just leave it at 2 kwach. So for today we can